we learned our basic differentiation rules. Up until this point, every time we've been asked to get a derivative, we've used the difference quotient. Well, as we move on in calculus and the functions get more complicated, we're going to see that using the difference quotient can sometimes be incredibly difficult, even impossible. Fortunately, there's some cool little tricks and shortcuts we can use to make getting derivatives a bit easier. Before we learn some of those tricks and shortcuts, let's make sure we know the different ways you can indicate a derivative. If the function is y equals x squared plus 3x minus 4, we can say the derivative of this is y prime. Now I happen to know the derivative of this is 2x plus 3. I'm going to say y prime is 2x plus 3. Another way I can indicate the derivative of y is to use this notation dy dx. This means the change in y over change in x, and that's precisely what slope is. Slope is a measurement of the change in y over change in x, and that's what a derivative is. A derivative is a formula we can use to calculate the slope of this anywhere we want. I'm going to say dy dx is 2x plus 3. Of course, we already know if our function is written in f of x form, we say the derivative of f of x is f prime of x. I'm going to say f prime of x is 2x plus 3. And this notation here, d dx of x squared plus 3x minus 4, just means the derivative of x squared plus 3x minus 4. And the derivative of x squared plus 3x minus 4 is 2x plus 3. And if you think about it, this notation is really the same as this notation, since y equals x squared plus 3x minus 4. This is dy dx. So here we have our 5 basic differentiation rules. Let's take a look at this first one called the constant rule. This says that the derivative of any constant number is 0. So let's go take a look at why that's true. Let's look at this function y equals 4. Of course, if you graph the line y equals 4, you get a horizontal line where y equals 4. And you can see the slope of that line is 0 everywhere. So I'm going to say the derivative y prime equals 0. And of course, that would be true if you graph y equals any number. F of x equals -3, that essentially just means y equals -3. Again, we have a horizontal line. So I'm going to say f prime of x equals 0. It doesn't matter what you plug in for x. It doesn't matter where you look on that line. The slope's always going to be 0. I'd have to say this next basic differentiation rule, the power rule, is the highlight of today's lesson. The power rule says that if we have to get the derivative of a variable with an exponent, all we need to do is take that exponent and move it into the front, and then subtract 1 from the exponent. Let me show you how that works. If y equals x to the third, the derivative of this, all I need to do is take that 3 and move it into the front, essentially turn it into a coefficient. Let me put that 3 in the front, and then I'm going to write my variable again, x. And I'm still going to have an exponent, but I'm going to subtract 1 from this. 3 minus 1 is 2. The derivative of x to the third is 3x squared. Let me share with you another simple example of the power rule. If f of x is x to the -2, then f prime of x, its derivative, all I need to do is put that -2 in the front, so -2x, and then I have to subtract 1 from the exponent. Well, -2 minus 1 is -3. Now, we've been saying how it's not proper to leave our expressions with negative exponents, so perhaps we can neaten this one up a little bit. -2 times x to the -3, well, that's the same as -2 times 1 over x to the 3. And we can, of course, think of -2 as -2 over 1. So -2 over 1 times 1 over x to the third. I'm going to say this is -2 over x to the 3. This sum and difference rule is quite simple. It essentially just says, if you have to get the derivative of something where there's 2 pieces like split up by addition or subtraction, all you need to do is get the derivative of the first piece and then get the derivative of the second piece. So let me show you what I mean. Let's get the derivative of f of x. I'm going to say f prime of x equals, and then I notice that f of x has 2 pieces split apart by an addition symbol. So all I need to do is get the derivative of this and then get the derivative of this. So the derivative of x to the third, I can of course use my power rule. Let's get the derivative of x to the third. Let me move the 3 in the front, so 3x, and then I'm going to subtract 1 from the exponent. 3 minus 1 is 2. And then I'm going to put this addition symbol, and then I'm going to get the derivative of this other term. And the derivative of 4, well, we just saw that the derivative of a constant number is 0. The derivative of 4 is 0. I'm going to say f prime of x equals 3x squared. Let's look at number 6 and get the derivative of y. Perhaps I'll use my other notation. Perhaps I'll use dy dx. The change in y over change in x, or the slope of this, all I need to do is get the derivative of these three pieces. So I can use my power rule to get the derivative of x squared. Let me move the 2 in the front, so 2x, and then I'll subtract 1 from the exponent, and of course 2 minus 1 is 1. So this is 2x to the 1. I think I'll just leave it 2x. Then I'll put an addition symbol. And now how are we going to get the derivative of x? Well, we can use the power rule. If we rewrite x, why don't we just think of x as x to the 1? And what I'm going to do is move this 1 in the front. I'll put 1 there. And then I'm going to have x. And I'm going to subtract 1 from the exponent. Well, 1 minus 1 is 0. And let's stop here and think about this. What does x to the 0 equal? Well, anything to the power of 0 equals 1. So what we're looking at here is 1 times 1. I'm going to say that piece is just 1. The derivative of x is just 1. Let me show you why. Here's the graph of the line y equals x. And notice it's a line. The slope of a line is the same everywhere. And what's the slope of this line? Well, this line goes up 1 over 1, up 1 over 1. The slope of the line y equals x is 1. Let's get back to finishing number 6. Now I'm going to put my subtract, and the derivative of 3, well, we know the derivative of any constant number is 0, so this would be minus 0. The derivative of x squared plus x minus 3 is 2x plus 1. It would be a little tedious to show you why, so at this stage in the game, I'm just going to ask that you trust me when I tell you that the derivative of sine of x is cosine of x, and that the derivative of cosine of x is always negative sine of x. Our last basic differentiation rule is what I call the constant multiplier rule. It says that if you're getting the derivative of a number times a function, well, all you have to do is get the derivative of that function, and you can just bring along the constant multiplier. So that's exactly what we have going on in number 7. We have this constant 3 times x to the 4th. So when I get the derivative, I can just bring along that constant multiplier of 3, and I'll just multiply that times the derivative of x to the 4. And to get the derivative of x to the 4, we can use the power rule. To get the derivative of x to the 4, I'll put the 4 in the front, so it's going to be 4x, and then I'm going to subtract 1 from the power. That would be 4x cubed. So our f prime of x would be 3 times 4x cubed, or f prime of x would be 12x cubed. In number 8, I have a constant multiplier. So the derivative of y, or y prime, will equal 2 times the derivative of sine of x. And the derivative of sine of x is cosine x.